Okay guys, welcome back. Today we're just going to look at integrating some new types of functions. So far, all that we know how to integrate is x to the n. So something like this, which would of course go to x7 on 7 and then plus my c. And this c is because it's an indefinite integral. Okay, so we just got to build up our tools of what we can integrate. What this here is saying, I'll just do an example so you can see how to use it, and then we'll prove how or why it works. It's just saying that if I have a linear function, 2x plus 3 to the 6 dx, I can just jump straight to here. That linear function will stay the same. 2x plus 3 raised to the power of 7, and I divide by the 7 and also the 2 being the a there. This is a simplified version of what we'll do next, but we will still run through and see why it works. First we'll see why it works with this particular example, okay? I'll just change the color of the pen and then we'll do it for a general case. If I say that y, I'll just use y instead of f of x, y equals 2x plus 3 to the 7. From here, I can differentiate. We know how to differentiate. I bring the 7 down, and I get 2x plus 3 to the power of 6, and then I get this 2 out. And that's of course because we have, well, the chain rule. If y equals f of x to the n, y dash or dy dx equals n f x n minus 1, and then I had this derivative and he was spat out. That's the derivative there that gets spat out. So in this example I can say if this is the derivative of this, then this is the integral of this. So let's write that. The integral of 7 2x plus 3 to the 6 times 2 dx is equal to 2x plus 3 to the 7 plus c. And that's because I'm doing, of course, indefinite integrals where I don't have to sub in. Now, we saw before with our properties, I can drag any constants through that integration sign. I could say that 7 by 2, I'm not writing that as 14. We're just leaving it as those factors, which will be useful for us to see why it works. To the 6 dx equals 2x plus 3, 7 plus c. So I haven't changed anything there, okay? Now what I'm going to do is just divide both sides by this. So the integral of 2x plus 3 to the 6 dx equals 2x plus 3 to the 7 divided by 14 plus c. Now why didn't I divide that c by 14? I really should do that. Thing is that it doesn't matter because it's just a constant. So I can leave it as c, or if I want I could write d. Okay, where d equals c on 14. Again, it's just a constant, so it won't matter. So now we can see that is in the form that we've got up here. Let's do in general. In general, I'll do that over here. If I have y, we'll do the exact same process, but just for ax plus b. Y equals ax plus b to the power of n dy dx equals n ax plus b to the n minus 1 times a. The derivative of this is this, so the integral of this is this. The integral of n ax plus b to the n minus 1 times a dx equals ax plus b to the n. So we're just writing it backwards. Okay, derivatives, integrals. Again, these n's and a's are constants. I can drag those through my integration sign. Okay, I can't do that with a function of x. I can only do that with a constant. Dragging them through, n by a, integral of ax plus b to the n minus 1 dx equals ax plus b to the n, dividing through by n times a, which is just what we did here. Integral ax plus b n minus 1 dx equals ax plus b to the n on n times a. Now this looks pretty similar to what we've got up here. I didn't mention this n can't be equal to -1. That's only because that denominator will become 0. But we'll see what goes on there. Just scrolling down a little bit to fit that in. To make that look exactly the same as what they have, I'm going to say, well, n equals n plus 1. So I'm going to move these powers, or these n's, they're all going to shift up 1. N will become n plus 1, n minus 1 will become n. Integral ax plus b to the n dx equals ax plus b n plus 1 on n plus 1 times a. And of course here I've done the critical error. Yes, I forgot my c. Plus c. Plus c. I'm just going to leave it as c there, okay? Where that's here I've got c. That's c on n times a, but doesn't matter. Plus c. Good. Pretty straightforward to use, and again this is simplified of what we're going to do further down, but let's just do a couple of examples, and I might leave some for you to do here as well. Here we go. Alright, let's zoom in there a little bit, make it a bit clearer. Right, 5x minus 9 to the power of 3. Using this guy here. Integral is blue. 5x minus 9 to the 3 dx equals 5x minus 9, raise the power, bring that power down, done, plus c equals 5x minus 9 to the 4 on 20 plus c. Now that's for an indefinite integral. We'll do b now. This is just your definite integral, where I'm just going to have to sub these values in, so it might be good to mix it up. Just going to jump straight to the second line here, equals 3 minus x to the power of 9. That raises up by 1. That 9 comes down, and the value of a here is the coefficient of x, which is minus 1. Now, instead of putting a plus c on the end, I'm going to put my bounds on. Substituting in 3 minus 3 to the power of 9, well, that's just going to be 0, minus 3 minus 2 to the power of 9 on minus 9 equals, that's just going to be 0. Now 3 minus 2 is 1, 1 to the power of 9 is 1, negatives will cancel, so I get plus a 9th equals a 9th. Okay, I'm going to leave that last one here for you guys to practice, okay? Obviously, I'll just give you a little head start. 4x minus 3 to the half. Half comes down, you'll be fine with that. Okay, so we have 1, we have 2. Now, I said before that this is a kind of a simplified version of something that will come. It's very useful to remember this. You'll often get a linear function in here, but what we're going to talk about now is any function. See, they've got f of x here. We had it as linear before, but it may not be linear. So, we're going to start with an example just to see how it works. What we want to be looking for something with the derivative of the inside just sitting out the front there. Okay, what this might look like, integral, my function is going to be x squared plus 4. And we'll put it to some power n, let's choose 8. Okay, what this wants is it wants my derivative sitting out the front. The derivative of x squared plus 4, which is non-linear, that's a quadratic function. The derivative is 2x. My dx on the end. And now this is telling me that I can just jump straight to my answer. And I can go, well, that is 1 on 9. X squared plus 4 to the power of 9 plus c. That's how it's going to work. I need my derivative here and my function here, and then I can use this form straight away. What I want to do now is show you how it works exactly like we did up there. Let's take this function here, this guy here, and we're going to say y equals x squared plus 4 to the power of 9. I know how to derive that very simply. I go dy dx equals 9 comes down, x squared plus 4 to the power of 8 times the derivative of the inside, that was the chain rule we mentioned, 2x. Now, just as I did before, if the derivative of this is this, the integral of this is this. The integral of 9 x squared plus 4 8 by 2x dx equals x squared plus 4 to the power of 9 plus c, didn't forget. Now I'm just going to take this 9 and bring that down, and I'm just going to rewrite the 2x and put it out the front. The integral of 2x, x squared plus 4 to the 8, dx equals x squared plus 4 to the power of 9, and then this 9 comes down, plus c. And that's it. That's in the form that I've got up here. That's the 9. That's the 9. My function is that. This is very useful. I'm definitely going to run through the general proof here, okay, guys? So I'm going to do the exact same as we did in the orange, just with any function. Right. If I take my function y equals f of x. I know that f of x to the n. I know that dy dx equals n f of x to the n minus 1. I don't need that bracket there. We'll just put another one in. Times the derivative. Therefore, so the integral of n f of x to the n minus 1 times f dash x dx equals f of x to the n plus c. Alright. Now, remember I said we can't drag a non-constant factor through the integrand. I don't know if this is non-constant. I don't know what this is. It's a function of x. It's some function of x. It could be 2. It could be 2x. If it's 2x, I can't drag it through. So I'm going to leave it. I'm only going to drag that n through. N integral, and I'm just going to write this, switch the order of those. F of x to the n minus 1 dx equals f x to the n plus c. And actually, let's just save a line. I'll divide by that n. I'll divide by that n, and then I'll put my c on, where again c is c on n, which is just another constant. So that looks like what I've got up here, but I'll just switch my n's and n pluses 1's. Integral of f dash x, f of x, n minus 1, add 1 to it, becomes n. Equals f of n equals n goes to n plus 1 plus c. And that's what I have up here. Let's do some examples. Excuse me. This guy here. Remember, we want it in the form f dash x equal, f dash x, f of x to the n. That's what we want. We want the derivative sitting out the front. If I had a different example, I would have 2x, x squared plus 1 to the third dx. That's fine. That's the derivative of this. But we don't have that. So let's just write it out. We say, well, the integral of x squared plus 1 to the power of 3 dx. What do I want sitting out the front here? I want 2x, because that's the derivative of this guy. What do I have? X. Well, that's okay. 2x. Everything's not the same, but to cancel that out, or to make everything in balance, boop, then I'm just timesing by 1. I know that this thing in here, I can just jump straight to the answer for that. That half is going to stay there. And this guy will just be the x squared plus 1 to the power of 4 on 4 and plus my c. Now that is going to be equal to x squared plus 1 all to the power of 4 on 8 plus c, where c is old c. We could call that c1 and c2 if we really wanted. Again, not really that important at this stage. Okay, let's do part B. Part B says Part B, find the exact value of that, x squared. Okie dokie here. I want my derivative of that. I'll rewrite. I don't like the radical sign. I prefer indices. Each to their own. Ah, that's much better. Whew. I want the derivative of this here. The derivative of x cubed minus 1 equals 3x squared. I don't have 3x squared. I've got x squared. I want to put a 3 in. If I have a 3 in, I divide by 3. Now I can jump straight to it. Sorry, I forgot my dx there. Equals a third. Well, that is just, everything kind of disappears. Everything just works out here because I'm using this form here, okay, that we're going to remember. That goes to a third. x3 minus 1. A half plus 1 is 3 over 2. If I divide by 3 over 2, it's the same as timesing by 2 over 3. Plus c. I don't need the brackets for that c because it gets sucked in. I'll tidy this up. What's that? 219. That's it. X cubed minus 1 to the 3 on 2. Actually, guys, I've done it again. We're doing a definite integral here. So I don't need that plus c. I can just put on my, because I've got these guys here, the moment I integrate, I can switch to this. 2, 1, 2, 1, and hopefully this won't create too much. I'm going to take that 2/9 out. Now you can play around with however you do it. These double brackets here, 2/9, so I'm just left with subbing the 2 in. I get, well, 2 cubed is 8 minus 1, which is 7. Seven to the 3 over 2. And then if I put the 1 in, I just get 0 minus 0. And then we get 2 over 9 by 7 to the 3 over 2, which is not very nice at all. Yeah, we could probably tidy it up a little bit. Let's just give it a quick go here. Equals 2 on 9. 2 on 9. And then that will be, well, the cubed root, that's 1.5, isn't it? So that would be 7 root 7. Should be 14 root 7 on 9. Okay, a little bit nicer. But you've got your answer here. You're done. That's it, guys. This is the big one that we want to remember. Okay. What I want to do just before we go, I'm going to come back to this guy here. 5x minus 9 cubed. We did this easy way, which you will remember, but I want to link it as to what we did there. 5x minus 9 to the power of 3. So let's go. Integral 5x minus 9 to the power of 3 dx. I want this in the form. I'm forgetting that just the linear case, because linear is just one case. We want it to work for anything. I want this in the form. Integral f dash x fx to the n dx. Then I can jump straight to the answer. This, let's rewrite it here for the big finale. That is not in this form. I don't have an f of x out the front. What is the f dash x? What is the derivative of this 5x minus 9? It's 5. If I times by 5, what do I divide by? 5, or times by 5th. Now I'm in the form f dash x, f of x to the n. So I can jump straight to my answer, which is that 5th stays there. 5x minus 9 to the 4 on 4. That's the exact same answer that we had before. It's just that form said to put that 5 on the bottom. Either way you do it, you win. Okay, that's today's lesson done. See you next time. Ciao.